Okay, we are here tonight for office hours for Module 3. Currently in the Zoom meeting room with nobody else in here, so I want to go through a few types of problems that you have in your assignment this week, just so you can see how they're done. First, we're going to start with regression. So here we have the case of Showtime movie theaters, and they would like to estimate weekly gross revenue as a function of their advertising expenditures. So we have data for a sample of 8 weeks. And what we're going to do is we're going to run a simple regression for the case where we just forecast the revenue based on newspaper advertising. Then we'll do a forecast where we forecast the revenue using just television advertising, and then we will look at a multiple regression where we look at the forecast using both television and newspaper advertising. So first we're going to start with newspaper. And in this case, the weekly gross revenue is going to be our dependent variable, and then the television advertising and newspaper advertising are the independent variables. So let's first look at the case with weekly gross revenue versus newspaper advertising. So I'm going to make a scatter plot. And in order to do that, I really need to rearrange the columns a little bit. So I'm just going to copy or move the weekly gross revenue and just delete this column. So now I can, it just makes for a better scatter plot. So we'll look at newspaper advertising as the independent variable and weekly gross revenue as the dependent. So I select both columns and choose Insert. And then under the charts, I'm going to look at Scatter. And I usually, when I use these charts, I will use a quick layout 1. This is newspaper advertising. That's in thousands of dollars. And then this is your weekly gross revenue. And we'll add a trend line. R square and display the equation. So when I do that, I get, I see a very, very small R square. And that's 0.00042. So there's essentially no linear relationship here. And then to continue on with that, I'm going to go ahead and do the use data analysis tools and use the regression tool. Our input Y range, which is the dependent variable, will be weekly gross revenue. Input X range, which is our newspaper advertising. I want the labels to show. I'm going to output this to K2. And go ahead and click OK. And I don't like all of these decimal places, so I'm going to set all of them to 3 decimal places. And here you see the R-square values. At 3 decimal places, it's too small to even show. I have to expand it to get 2 significant digits. So I've got the R-square of 0.0042. There's basically, since R-square is less than 0.10, there is no relationship. Looking at the significance F, it is high. We would usually be doing a significance test against alpha equals 0.05. So this is high. This is greater than alpha, so we would not have a significant relationship.
How do I open this?
And just to write down the relationship that or the estimated regression equation here, I'll just say revenue is equal to the intercept, which is 93.856 minus 0.043 times newspaper advertising. Like I say, that didn't display a very good relationship. It was not significant, and the R-square was extremely low. So we're going to skip doing the other simple linear regression, and I'm going to do a multiple regression where weekly gross revenue will be the dependent variable, and television and newspaper advertising will be used. And since there's 2 independent variables, I can't do a scatter plot, so I'll just skip that step. Go back to the regression tool. Notice that the input Y range hasn't changed. However, the input X range is going to encompass television and newspaper advertising. And I'm just going to go ahead and send my output into K28. Click OK. Let me set my decimal places again. Now, when you're doing multiple regression, you want to use the adjusted R-square. And I see here that the adjusted R-square is 0.887. And general rule that I use is if the R squared or adjusted R squared is greater than 0.65, then a strong linear relationship exists. So I'll just type in there, since adjusted R squared is greater than 0.65, strong linear relationship indicated. See, the significance now is 0.0019. That would be less than alpha of 0.05. So we would have a significant relationship. And so I'll just say significant. And as far as my estimated regression equation here, using these coefficients, I will have revenue is equal to 83.23 plus 2.29 times TV ads plus 1.301 times newspaper ads. So let's find out what the revenue would be if we spent $5,000 on TV ads and $5,000 on newspaper ads. So we want the revenue with 5,000 for TV, 5,000 for newspaper. So I'll use the coefficients from the worksheet to calculate. So this is going to equal to the intercept plus the TV ads coefficient times 5, because we're spending $5,000 and this data is in thousands, plus the newspaper ads coefficient times 5,000, because we're spending 5,000 on newspaper ads, and then I'll enter. So it looks like our revenue would be $101,186. Many of the questions on the quiz will give you the estimated regression equation and have you make the calculation based on numbers they give you to input. So you may have to work those out, but you'll probably, while you're taking your quiz, will just want to do it in either your calculator, or you can do it in Excel. But you don't have to. All you have to do is find the answer that's closest to the multiple choice answer. Okay, so that's the extent of the type of regression that you'll have on your homework assignment. Now, another type of problem in your homework is one, I'm going to change to a different file. And here, we're given the sales of Comfort brand headache tonic for past 10 weeks at Roscoe Drugs. So we'd like to analyze this pattern, but most importantly, they also want to, let's compare it using a 3-week moving average, and then we'll compare that to using a exponential smoothing with a alpha value of 0.4. So here's the data. Whenever you do a time series or forecasting, it makes sense to go ahead and make a time series plot. So in a time series plot, it's just like a scatter plot, except the independent variable will always be the time. Here it's in weeks, and the dependent will be the sales or revenue. So here I'm going to go ahead and make that time series plot. So insert scatter with straight lines and markers. And I'm going to switch this over to quick layout 1, just like I did before. And here we have week. And then we have sales. I'll just call this comfort tonic sales. And when you look at the pattern on this, this is a what we would call a horizontal pattern. You may ask, well, how do you know that? Well, for one, it's not seasonal because it doesn't have a seasonal oscillation. For example, a seasonal pattern would go like here. I would be at the bottom to the middle, the top, back to the middle, back to the bottom. But you see how instead of going back to the bottom, it goes up again. And so that breaks any kind of seasonal pattern. So it will be a random pattern, and it's horizontal because it's really not going to have. If I added a trend line, and see my R-square value here for that trend line is less than 0.1. So I don't consider that there's a trend unless the R-square value is greater than 0.1. So here that's not true. So it's just a horizontal pattern. Okay, now I'm going to run the 3-week moving average. What I want to observe in this is I want to observe the mean absolute deviation, or MAD, the mean square error value, and the mean absolute percent error. And then when I run the exponential smoothing, I'll look at the same values and compare those to what I got for the 3-week moving average. And whichever forecast has the smaller values will be considered to be the more accurate forecast and would be the one that we would prefer to use. See, we have 10 periods. I'm going to go ahead and run Excel QM. Forecasting, I'm going to do a moving average. So my number of past periods is 10. And I'm doing a 3-week average. And I'll go ahead and show the graph. And click OK. Now, I need to go ahead and paste in the actual data values from my original problem. And then once I do that, you see I've got a graph now, and I have actual values. I'm going to set these decimal places. Okay, so here are my MAD, my MSC, and my MAPE values. And then over here, if I use this forecast, the next period, which would be period 11, would have a value of 118.333. Now I'm going to run this again. This time I'm going to do exponential smoothing and then use an alpha of 0.4. So QM, forecasting, exponential smoothing. I have 10 past periods. And I'm just going to leave graph checked like I did before. Click OK. And now, of course, I've got to get my data. And enter my alpha, 0.4. And there we go. We have the data. I just like to have fewer decimal places so it's not so confusing looking. And here's my MAD, MSE, and MAPE. If I choose this one, I will get a next period forecast of 121.821. So now what I'm going to do is I'm going to copy these MAD, MSE, and MAPE, and I'll just paste them in. What I want to do is I just want to go ahead and just paste in the values. So I see now this table on the bottom is what I pasted in from the exponential smoothing. So for MAD, the exponential smoothing is lowest. For mean square error, the 3-week moving average is lowest. And then when I look at MAPE, the exponential smoothing is lowest. So since exponential smoothing has 2 of the 3 forecast error measurements that are smaller, I'm going to say that the more accurate forecast based on MAD and MAPE is exponential smoothing with alpha equals 0.4. So you'll have a problem where you have to make a comparison like that. That's what you base it on, is which has the most or the smaller magnitude of the forecast accuracy measures. Okay, the last type of problem is I'm going to go down here and use this TV sales data. We've got TV sales. This is TV sales for a period over the past 4 years. It looks like there's an increasing trend, but all I have is this table. And then when I look at the data, the table is a little bit broken out, but I have to actually insert a period variable in order to create a time series plot. Period variable is just consecutively numbered. So now I'll go ahead and create my time series plot. Quick layout 1. This is the period, which is in quarters. And then this one is the sales in 1000s. All right. And so it definitely looks like there's a seasonal pattern to it. And if I go ahead and add the trend line, display the R square, note that now I have an R square of 0.505. So, and that confirms that there's a trend, and I have a seasonal pattern. So this is a seasonal with trend pattern. Okay. So the question is going to ask you to use a technique called multiplicative decomposition to solve this using the centered moving average. And I think this, I'm hoping that my software works for me for this. This is going to be forecasting multiplicative decomposition. The number of past periods of data is 16. The number of seasons is 4. We're going to use the centered moving average method and then click OK. So now I have to actually just paste in my data. Oops. Okay. It's a lot to look at in this screen. I'm just moving that out of the way. To make it a little bit more clear, I'm going to go ahead and set decimal places all over the place here to make them 3 or less. There's more stuff down here too. Okay, so what am I looking at? The question usually wants to know what would be the equation of the line for the trend line equation. That information is contained here. So here we would have y is equal to 5.1 plus 0.147 times x. That would be our trend line equation. And then they'll usually want to know what the seasonal adjusted forecasts are. So basically, you've got an unadjusted forecast. It gets multiplied times the seasonal adjustment, and so you have an adjusted forecast. And the adjusted forecast is what we're after. So what we're saying is that for the next year, which encompasses periods 17, 18, 19, and 20, our seasonally adjusted forecast will be 7.086, 6.491, 8.632, and 9.195, respectively. That's basically how the methods that are used to solve the homework assignment problems for this week. I hope you are able to cope with that and manage to get that completed. These problems are due by Sunday night at 11:59 p.m. Since there's no one else here with me, I'm going to go ahead and sign off. I hope that this is helpful to you.